Nios II is a 32-bit embedded processor architecture designed specifically for the Ultra family of FPGAs. Nios II incorporates many enhancements over the original Nios architecture, making it more suitable for a wider range of embedded computing applications, from DSP to system control. Nios II is comparable to Microblaze, a competing soft-core CPU for the Xilinx family of FPGA. Unlike Microblaze, Nios II is licensable for standard cell ASICs through a third-party IP provider, Synopsys Designware. Through the Designware license, designers can port Nios-based designs from an FPGA platform to a mass-production ASIC device. Nios II is a successor to Ultra's first configurable 16-bit embedded processor Nios. Key features: like the original Nios, the Nios II architecture is a RISC soft-core architecture which is implemented entirely in the programmable logic and memory blocks of Ultra FPGAs. The soft-core nature of the Nios II processor lets the system designer specify and generate a custom Nios II core, tailored for his or her specific application requirements. System designers can extend the Nios II's basic functionality by adding a predefined memory management unit, or defining custom instructions and custom peripherals. Custom instructions similar to native Nios II instructions, user-defined instructions accept values from up to two 32-bit source registers and optionally write back a result to a 32-bit destination register. By using custom instructions, the system designers can fine-tune the system hardware to meet performance goals, and also the designer can easily handle the instruction as a macro in C. Custom peripherals for performance-critical systems that spend most CPU cycles executing a specific section of code, a user-defined peripheral can potentially offload part or all of the execution of a software algorithm to user-defined hardware logic, improving power efficiency or application throughput. Memory management unit introduced with Cortex 8.0. The optional MMU enables Nios II to run operating systems which require hardware-based paging and protection, such as the Linux kernel. Without an MMU, Nios is restricted to operating systems which use a simplified protection and virtual memory model, for example, a Micron Linux and FreeRTOS. Memory protection unit introduced with Cortex 8.0. The optional MPU provides memory protection similar to that provided by an MMU, but with a simpler programming model and without the performance overhead associated with an MMU. Nios II CPU family. Nios II is offered in three different configurations: Nios IIF, Nios IIS, and Nios IIe. Nios IIF The Nios IIF core is designed for maximum performance at the expense of core size. Features of Nios IIF include separate instruction and data caches, optional MMU or MPU, access to up to 2 GB of external address space, optional tightly coupled memory for instructions and data, 6-stage pipeline to achieve maximum DMIPS MHz, single-cycle hardware multiply and barrel shifter, optional hardware divide option, dynamic branch prediction, up to 256 custom instructions and unlimited hardware accelerators, JTAG debug module, optional JTAG debug module enhancements, including hardware breakpoints, data triggers, and real-time trace. Nios IIS Nios IIS core is designed to maintain a balance between performance and cost. Features of Nios IIS include instruction cache, up to 2 GB of external address space, optional tightly coupled memory for instructions, 5-stage pipeline, static branch prediction, hardware multiply, divide, and shift options, up to 256 custom instructions, JTAG debug module, optional JTAG debug module enhancements, including hardware breakpoints, data triggers, and real-time trace. Nios IIe The Nios IIe core is designed for smallest possible logic utilization of FPGAs. This is especially efficient for low-cost Cyclone II FPGA applications. Features of Nios IIe include up to 2 GB of external address space, JTAG debug module, complete systems in fewer than 700 LEs, optional debug enhancements, up to 256 custom instructions, free, no license required. ALll Switch Fabric Interface. Nios II uses the ALll switch fabric as the interface to its embedded peripherals. Compared to a traditional bus in a processor-based system, which lets only one bus master access the bus at a time, the ALll switch fabric, using a slave-side arbitration scheme, lets multiple masters operate simultaneously. Development processes. Development for Nios II consists of two separate steps, hardware generation, and software creation. Development is hosted inside an ALll application called the Embedded Design Suite. The EDS contains a complete integrated development environment to manage both hardware and software in two separate steps. Hardware generation process. Nios II hardware designers use the QSYS system integration tool, a component of the Cortex-II package, to configure and generate a Nios system. The configuration graphical user interface allows users to choose the Nios II's feature set, and to add peripheral and I/O blocks to the embedded system. When the hardware specification is complete, Cortex-II performs the synthesis, place and route to implement the entire system on the selected FPGA target. QSYS is replacing the older SOPC builder, which could also be used to build a Nios II system, and is being recommended for new projects. Software creation process. A separate package, called the Embedded Design Suite, manages the software development. Based on the Eclipse IDE, the EDS includes a C++ compiler, debugger, and an instruction set simulator. EDS allows programmers to test their application in simulation, or download and run their compiled application on the actual FPGA host. Because the C++ development chain is based on GCC, the vast majority of open-source software for Linux compiles and runs with minimal or no modification. Third-party operating systems have also been ported to Nios II. These include RTOS, Micrium MicroCOS II, ECOS, ChibiOS RT, i1 Cortex Linux and FreeRTOS. References. See also, Lattice MIG08, Lattice MIG032, MicroBlaze, PicoBlaze, Micon P200. External links, Ultra site about Nios II, Nios Users Community Forum, Nios Community Wiki, RTEMS Real-Time Operating System, Cornell ECE 576 Microcontroller Course using Nios II, FreeRTOS Demo Documentation for Nios II, UPB ECE 31289 Course using Nios II.